In this problem, we need to resolve the given rational fraction into partial fractions. Now, here, the given rational fraction, this fraction is not a proper rational fraction because the degree of the numerator is greater than the degree of the denominator. To check that, all we have to look is for the highest degree or the highest power of x in the numerator, that's 3, whereas the highest power of x in the denominator is 2. All we have to do is reduce it to reduce the degree of the numerator such that it becomes less than that of the denominator. We will have to perform a long division. To perform a long division, all we have to do is consider the numerator, which is x cubed minus 6x squared plus 10x minus 2. And we will be dividing it with the denominator, which is x squared minus 5x plus 6. Now we need to multiply x squared minus 5x plus 6 with in such a fashion so that we get the first term equals to x cubed. So that should be x. So x squared times x will become x cubed. Then negative 5x times x will become negative 5x squared. Then positive 6 times x will become positive 6x. So that means we will now have, so we'll subtract it, x cubed and x cubed goes away, 6x squared minus 5x was going to give us negative x squared. Then we have 10x minus 6x, so that's positive 4x minus 2. Further divide negative x squared plus 4x minus 2 with x squared minus 5x plus 6. So this time we're going to multiply with negative 1, so x squared times negative 1 will become negative x squared. Negative 5x times negative 1 will make it positive 5x, and positive 6 times negative 1 will be negative 6. Now again we will subtract, so we will get 4x minus 5x, so that's negative x. Negative 2 minus 6 will be positive 4. So this is going to be our remainder. So this is our remainder. We have x minus 1, so this is going to be our quotient. Then we have the divisor. So we only need these three things. That means we can now rewrite this as we have the quotient, which is x minus 1, plus the remainder, which is negative x plus 4, whole divided by the divisor, which is x squared minus 5x plus 6. Right. That meant now we can rewrite it as x minus 1 minus x minus 4 whole divided by, we have x squared minus 5x plus 6. So that can be factorized to get x minus 3 times x minus 2. So this is our original partial fraction, original rational fraction, which has been broken down into x minus 1 minus, now here our rational fraction where the degree of the numerator is less than the degree of the denominator. So we're going to label this as equation number 1. So we will try to resolve this third term, which is x minus 4 divided by x minus 3 times x minus 2 into two partial fractions. That's because we have two factors here. So this will get broken down into a over x minus 3, and this is our first partial fraction, plus b times over x minus 2. This is going to be our second partial fraction. So a and b are constants, and we need to find out its value. Now, in order to find out the value of a and b, we're going to multiply both sides of the equation with x minus 3 times x minus 2. So this is going to give us x minus 4 will be equals to x minus 2 times a plus x minus 3 times b. To find out a and b, we're going to choose two specific values of x. So let's say we take x to be equals to 3. So if we take x equals to 3, we're going to get 3 minus 4 equals to 3 minus 2 times a plus 3 minus 3, so that will become 0. We have negative 1 equals to a, or simply a equals to negative 1. Then to find out the value of b, we are going to choose x equals to 2 because that will get rid of the first term. So 2 minus 4 equals to 0 plus 2 minus 3 times b. So 2 minus 4, that's negative 2 equals to 2 minus 3, so that's negative b, or b value simply equals to positive 2. Now we have x minus 4 divided by x minus 3 times x minus 2. So this will be equals to, we have negative 1 divided by x minus 3 plus 2 divided by x minus 2. So we'll substitute this value back into our original equation, which is equation number 1, and this should give us, so our final answer is going to be x minus 1 plus 1 over x minus 3 minus 2 over x minus 2. So this is the final value.